morning my dear friends and students. Welcome back to Ravi Maths Space channel. Today we are going to learn and discuss the very most important topic, that is exercise 1.4 of real number chapter. So today we are going to solve the exercise 1.4 problems. Okay. In the first problem is, also see what is the first problem here. Without actually performing the long division, state whether the following numbers will have terminating decimal expansion or non-terminating decimal expansions. So already we know. What we know? Every rational number has either terminating decimal expansion or non-terminating decimal expansion. Here condition is what here? Without doing long division. Without doing long division. So if you not apply long division means, then what condition we are going to check here? Yes, we are going to check three theorem statements. Already these three theorems I explained in the previous video. I will provide the link in the description box. You can watch that videos, then you can understand very easy. Okay, based on these three theorems, we can say given rational numbers has terminating decimal expansion or non-terminating decimal expansion. Okay, so if you want to identify which is terminating decimal expansion or non-terminating decimal expansion means, what condition we are going to satisfy here? Very simple here. In the rational number, the denominator should be satisfy the condition is 2 power n into 5 power m. 2 power n into 5 power m. If it is satisfied, this rational number consists as a terminating decimal expansion. Otherwise, non-terminating decimal expansions. Okay. So remember what condition we have? The denominator. Suppose it is in the form of P by Q. So what is the denominator here? Q. What is the denominator here? Q. Q is of the form, should be how it is? 2 power n into 5 power m. If it is denominator satisfy this condition, it has terminating decimal expansion. Otherwise, non-terminating decimal expansion. Okay. Now, take the first problem. What is the first problem here? 13 by 3125. So, in this rational number, denominator check. What is the denominator number here? The denominator is here. What is the denominator? 3125. 3125. This denominator, check whether it is in the form of 2 power n into 5 power m or not. Okay. First, what we should find out here? We are going to find out the prime factorization of this number. How to find out prime factorization? So we have so many methods are there. Now we can find by using long division method easily. So this number is divisible by 5. How? Why? Because this number at the end, once it is consists of 5 or 0 means it should be divisible by 5. That's why I am taking here 5. So 5 6 30, 5 2 10, 5 5 25. Understand here. Next 625 we got. Again 625 into 5 means 5 ones, 5 twos, 5 fives. Again with 5. 5 twos, 5 fives. So 25 means 5 fives. So total how many 5s came here? 1, 2, 3, 4, 5. The prime factorization of 3125 is 5 into 5 into 5 into 5 into 5. So this we can write as a simply 5 power 5. Simply 5 power 5. Okay. Now tell me children, this 5 power 5, is it in the form of 2 power n into 5 power m? Actually here only one factor is there, that is 5. Where is other factor 2? Yes. But this 5 power 5 we can convert into 2 power n into 5 power m. How? Once see here. Actually this 5 power 5 I can write as a 1 into 5 power 5. Meaning is, why 1 here? 1 is the factor of all numbers. So here no need to write 1 here everywhere. If you want means we can take here. So 1 into 5 power 5. So this I can write as a, this one I can write as a 2 power 0. Already we know a to the power of 0 is equal to 1. So by using this, can we write 1 instead of 1, 2 power 0 into 5 power 5. Now check out. Denominator is of the form 2 power n into 5 power m or not? Yes, it is in the form of 2 power n into 5 power m. What is the n and m values here? Here n is equal to 0, m is equal to 5. M is equal to 5. Therefore, the given rational number 13 by 3125 has terminating decimal expansion. So, which is terminating decimal expansion. Like this, all problems we are going to check. Understanding here. So in the same process you have to apply. Okay, let's see second problem. What is second problem? 17 by 8. If you are watching first time my YouTube channel, please do subscribe and share to your friends. It is useful. 17 by 8. 17 by 8. Yes, by seeing only we can say. So denominator is what here? Second problem denominator 8. What is the prime factorization of 8? 2 cube. So this 2 cube I can write as a 2 cube into, here 1 is there, this 1 I can write in the form of 5 power 0. Again 8 is in the form of 2 power n into 5 power m, meaning is in the form. So it's also consists as a terminating decimal expansion. So this also consists as a terminating decimal expansion. Next, 64 by 455. Now third one. What is? Third denominator is 455. Third denominator is 455. Yes. 455. What is the prime factorization? Find out here. 455. So smallest prime number we should take. Already here 5 is there. One's place means this number is divisible by 5. When it is 5 sevens, 5 nines, 45, 5 ones. Next, 91. So 91, which number? Yes, 13 table, 13 sevens, 91. So 7 ones, 7. So what is the 455 prime factorization here? 5 into 7 into 13. Meaning is what here? See here. This prime factorization is not in the form of 2 power n into 5 power m. Why? Because here 5 is there, but here other factors are involving here. Meaning is what here? When other factors are involving means automatically that is not in the form of 2 power n into 5 power n. So this number, this rational number does not consist terminating decimal expansion, but it consists non-terminating repeating decimal expansions. Understanding here? So non-terminating repeating decimal expansion consists. Terminating decimal expansion not consist. Understanding here? Yes, it is here non-terminating. It is for non-terminating decimal expansion. Okay. Next problem. Fourth problem C. Yes. What is the denominator number? Fourth problem 1600. 1600. Now 1600. Yes. How we can write here? 1600. See here. Prime factorization. 2 800. 2 400s. 2 200s. 2 100s. 250. 225. 5 5s. Therefore, 1, 2, 3, 4, 5, 6. 2 power 6 into 1, 2. 5 is repeating 2 times. Yes or no? Yes. Denominator is of the form 2 power n into 5 power m. Therefore, 15 by 600 consists terminating decimal expansion. Terminating decimal expansion. Okay. Next problem is 343. So, denominator is 343. What is the prime factorization of 343? Already we know 343 is a 7 cube. 7 cube. So, prime factorization of 343 7 cube. It is not in the form of 2 power m into 5 power n. Therefore, 29 by 343 does not consist terminating decimal expansion, but which consists what it is? Non-terminating repeating decimal expansion. Understanding here? Yes, this is not non-terminating. Non-terminating. Next problem is what here? Sixth problem. Yes, by seeing only we can understand. Sixth problem, denominator is in the form of, what is denominator in the form of? Already it is 2 power m into, direct is given here, no need to find out prime factorization also they only given. So therefore it consists as a terminating decimal expansion. Now we will see here, what is the denominator is of the form? 8th problem, 2 square into 5 power 7 into 7 power 5. See here 2 is there, 5 is there, but 2 other factor also here involved. Already we know it should be in the form of 2 power m n into 5 power m only. Other factor should not be involved. Here 7 is other factor, so it not in the form of 2 power m into 5 power n. Why? Because here 7 is another factor here involved. So this also direct is given here, prime factorization denominator here. Just to check out, it is also non-terminating recurring decimal expansion consists, but it does not consist terminating decimal expansion. Why? Because it is. Next problem, ninth problem. Ninth problem, denominator is what symbol here? 50. Denominator, how I can write here? So 50 prime factorization C. So 225, again 5 5s. So 2 into 5 square. Direct I am writing here. So 2 into 5 is repeated 2 times. So it is in the form of 2 power n into 5 power n. So which consists terminating decimal expansion, ninth one. This also terminating expansion. This is not. Next one is what here? 10th one. What is 10th one denominator here? Yes, I am writing here. See, space is not there here. I am writing here. What is 10th? Denominator is what here? 210. 210 prime factorization, 210 prime factorization, see 210 prime factorization, 2 ones, 5s. Again 5 is there, ones digit means 5 twos, 5 ones. Again 3 sevens, again 7. So here 2, 5, 3, 7. So I can write 2, 3, 5, 7. So here 2 and 5 there, but other factors here involving here. So other factor also there means it is not in the form of 2 power n into 5 power m. So 10th rational number does not consist the terminating decimal expansion, but which consists non-terminating repeating decimal expansions. Understand here? Like this simply way we have to check. So once again see terminating decimal expansion. This rational number also. This is non-terminating, non-terminating repeating decimal expansion. Now here terminating decimal expansion. Here non-terminating repeating. Here terminating. Here non-terminating. Here terminating. Here non-terminating. Just by seeing the inspection. Just these two formulas. Which two formulas? This one. Denominator is of the form just 2 power n into 5 power m. There are not. Checking means enough. I hope all children understand the concept clearly and detailed. If you understand the concept, please do subscribe, and it is useful. If you feel means share to your friends. Until